anything you say may not and will not be used against you. So feel free to speak freely, okay? But even though it's recorded. Anyway, going back to this, he said the state budget is wretched, or in a wretched state. And so we're going to get a cut of 5 to 7%. And this is only the 12th year in a row that we are getting cuts in the state budget. So only a relatively small portion of the university's budget is actually from the state. So the impact is not as big, but still 7% of this, what the state portion is still going to feel that. So hopefully you'll never have to describe your budget as wretched after you graduate from school. I mean, that's why you're in CIS, right? Okay. So that's what this class is for. Oh, my apologies. Right. Now, what I mean in this class for the rest of the semester until Derby is that whenever I say CIS, I mean the students in CIS plus the 2 accounting students. All right? So please understand that's what I mean. So any questions about the class, the assignment, which you have read? What I'm going to do is to finish the chapter today, and towards the end of the class, I'm going to go over the assignment. We don't have class on Monday, right? And the assignment is due on Wednesday. You should expect to see the second assignment posted sometime this weekend, hopefully. I think we went a couple of slides after that, but we talked about the file systems and its complexity and how difficult it is to use a file system. So the reason that we want to go through this is because looking at the problems associated with the typical file system is going to help you understand the design considerations later on when we talk about database design. So we went through that, and we talked about that, and we actually stopped on this slide, I think. So this is a typical file containing information about customers and their attributes, and then we define those terms. And this is a typical situation if file systems are used. You have each department having their own files, and more importantly, having their own programs that update, maintain those files. So as a result, you end up having different versions of the same data. For example, the same customer data may be repeated across several different files. And as a result of update to one of those files, but not updating the same record in other files, you may end up with inconsistency in the database. And we'll talk more about that later. So even though file systems were an improvement in the 70s, they also created a lot of problems. And ad hoc queries are impossible, meaning, for example, today, after the president received an email from Bashir, he may decide, say, for example, to find out about the current budget status. So he may start asking questions about where the cuts can be made, right, with the least impact on the university's operations. And that could lead to queries having to be made that are not part of the normal applications features, because those were things that the applications didn't anticipate. So those are ad hoc queries. For example, you may want to find out how much the annual budget is for a particular unit, such as the college business, and what's the trend of the budgets, right, for the last 10 years. So that's information that you have to write a query for. And writing a query would be an ad hoc query. And in a file system, you would have to write a program to do that. And sometimes it may take 30 days for a complicated file system to write an application against a complicated file system. So that's why we mean ad hoc queries. Changing existing structure can be difficult. The example I gave Monday is that you have names, and the structure of the names could be changed. And if you say, for example, the simplest example is increasing the length of the field, and you have to push everything, okay, to the right. And so these are some of the common problems. So you have extensive programming, and every time you want to do something, you have to write a program. And as you can see in SQL, it is much simpler. Cannot perform ad hoc queries. System administration is complex and difficult, but it kept a lot of people gainfully employed. And difficult to make changes to existing structures. And when we study database, you'll appreciate why it is much easier in database. Security features, because you have a bunch of files, and they're really difficult to maintain security. These concepts are important. I do not expect you to fully understand them today or this month. But sometime next month, you need to really understand what they mean. But I will introduce them today. Structural dependence means that changes to the structure of a file or the underlying database, right? It can be a file, it can be a database, it can be anything that's used to store data. What it means is that if you change the structure, then the applications or the programs that access the structure, the stored data, would have to be changed. That's called structural dependence. Structural dependence is undesirable. If you recall, we have applications and you have data, right? And in data you have structures. And the data here, of course, could be files, or they could be a database, set of database tables. If you change the structure, then in a file system, then you have to change the applications. For example, think of C#. If you change the order of the fields, that's changing the structure of the file, then the way you read the content into an object would have to be reprogrammed or modified. And that can take a lot of time. And you know that even though with object-oriented programming, changes at the top can be propagated to lower level classes in the class hierarchy, it is still quite a bit of change. And a huge, large application usually contains thousands of classes, at least hundreds of classes. And those changes would have to be checked and tested, and that could take a lot of time. And with most businesses, when you have a production system, that's what we call it, a system of use, and the business depends on that, and any changes can be very disruptive to the business, which may result, of course, in less revenue or disrupted services to customers. So it's not good. So that's structural dependence. And we also have data dependence. meaning that if the types of the data change, for example, you change from integer to real, then your programs have to change. Now, with file systems, data dependence is prevalent, right? It is very, very common. And it is also undesirable. So the whole idea is that you want to be able to make changes to your data without affecting your applications. Now, that's almost impossible. But with a file system, you almost always have to make changes to your applications. If you make changes to your data, either the data types themselves or the structure of the data. And with a relational database, it's relatively structural independent and data independent. It's not absolute. With relational database models, you don't have as much, in fact, you have much less structure dependence and data dependence. I'm going to reinforce that throughout the entire class so you can see the relevance of those concepts. And I know that you probably have heard about this, that is the distinction between logical and physical definitions. In a database file, we have a file. We know what a file is, right? We have data eventually stored in a sequential structure. You know what a storage device typically is like, right? It's a CD or something like that, and it contains concentric circles. And your data will be stored on these so-called tracks. This is a track, this is a track, and this is a track, and so on and so forth. And so your data will be placed byte by byte on these tracks. Okay. And so therefore, it's sequential. Even though this is the physical format. Now, logically, you don't have to think of your data as sequential, because then it would make things really difficult for us, right? We are three-dimensional creatures. Right? Some of us are more than three-dimensional. If you talk to mathematicians, usually they think in more dimensions, in 3 dimensions or 4 dimensions. So sometimes it's necessary to structure information in such a way that they have multi-dimensions. You see that later on in this class. And so therefore, you have this dichotomy between logical and physical structures. So in this class, we are not particularly excited about the physical formats. In fact, we're shielded from it. And so we're going to focus on logical structures. And logical structures are structures that typically conform to, very close to, how business processes are structured. Right? There's a very close relationship between the two. And this is becoming more and more common. And I don't know if you have seen the sci-fi series Voyager. It's really old. Okay, older than you probably. And in that sci-fi series, if you have watched it, you see they program. And that's how I envision people program. It's just putting blocks together, right? Leaving the details, leaving the nasty details for the computer to figure out. We're getting close to that, but it's going to take another 20, maybe 50 years. So in your career, you're going to see that. But I think for a very, very long time, meaning relative to the lifespan, career span of a human being, we're going to still need people that can do the dirty work. Right? That's companies are still hiring. if you have worked at a large organization and you have seen their systems, you understand why they need people that can understand code. Code of all kinds. And I have a neighbor who's a managing partner of Ernst & Young, and the two accounting students will know what the company does. It's one of the largest accounting firms. And they're an auditing, one of the main businesses is audit. And he said, finding information is like peeling an onion. The information is buried inside an onion. Right? And you have these layers and layers of information technology or programs. That's why we have accounting students taking this class. And I know an accounting student who took my Greg, I forgot his last name, Greg Maggard. He was taking my class, database class. When he was taking the class, he was co-opting for an accounting firm doing IT auditing, right? And he was making $5,000 a month plus a big company car. It is very difficult to find people that can understand both the domain and technology. So keep that in mind, all right? Now, it is difficult for a business person without formal training to understand information technology. As you probably could tell by this point, right? You've taken quite a few classes. It's really difficult for them, especially after a few years' work. Okay, it's relatively easy for an IT person to understand the business. Relatively easy, but it doesn't mean that you don't have to go through. So those two ladies, of course, are in a unique position in that they understand accounting, and then, of course, they also understand technology, right? They have some in-depth understanding of technology. So that's, I'll talk more about stuff like that, because you're thinking about careers, you're thinking about graduating, finding a job. And so I've done a lot of work outside school, programs, projects, and that's what I have seen. If you understand the business, when they hire, say, a database person, they just don't require Oracle skills, Oracle is database product, right? They say Oracle and human resource. They say Oracle and manufacturing. And if you just understand Oracle, you're useful, but you're not as useful. So anyway, going back to this, we have now come to one of the most important slides, right, in the first half of 2012, at least to you, data redundancy. Data redundancy is evil. Data redundancy is to be avoided as much as possible, and as you can see in the first few chapters of the book, data redundancy is the culprit for most of the problems in the database. So we want to reduce data redundancy to a minimum. And simply defined, data redundancy is the same piece of data stored unnecessarily in different places. Now, sometimes it is necessary to store the same piece of data in more than one place. By place, I mean one table. Okay. You know what a table is, right? A table is a two-dimensional structure, columns and rows. So data redundancy refers to unnecessary storage of the same piece of data in more than one place. So that's what it is. And that can lead to a lot of problems. Most importantly, it can lead to data inconsistency. Now, I want you to take a look at the end of the chapter. Okay. Please turn to page 27. And take a look at P1.1, the picture, P1.1. So data redundancy can be a problem, right? So let's first of all spot redundancy. Can you see any redundancy? Any examples of redundancy? In other words, the same piece of information repeated. Yes?
The manager phone and manager address.
Phone and address. Give an example, a specific example.
It's the same manager phone for the project manager and project manager. George F. George.
So for George, his information is repeated, right? How many times? Twice. Okay. And did you all see that? So that's an example of redundancy. Now, redundancy can lead to inconsistency. And why? Because when you have a set of data that you have, such as the one given in T1.1, you have to what? You have to update it, right? You have to add to it. And you may have to remove some data from it. All of those operations are operations that you have to have in order to maintain a live set of data. But the problem is that if you have redundancy, those operations can lead to inconsistency. And let's take a look at update, right? Let's take a look at George. So if you update George, for example, and his phone number is changed, right? And if you change it in one row and do not change it in the other row or rows, and you're going to have a problem, right? You're going to have inconsistency. So this is a very, very simple example. Most problems are much more subtle than this. That's why we're going to spend about a month or so talking about this and how to design a database to avoid these problems. But this is a very simple example so that you can be introduced to such problems. I hope you can all see that. So let's update. Insertion, for example, if George is given responsibility to manage another project, so another row is going to be inserted into the table. And again, his information might be entered incorrectly, right? Name, address, or whatever you have for George may be entered incorrectly. That again would lead to consistency, right? And then of course you have deletion anomalies. Deletion anomalies usually have to do with it can lead to inconsistency as well. If you want to delete George and you delete only one instance of it, you leave another instance of George in the database. So when people go to the database to retrieve information, they would still find George, right? When George is actually not part of the company or no longer managing projects. So that's an example of deletion. And this has a much worse problem in case of deletion, but we won't talk about it right now. Any question, discussion at this point? So you should be able to, if I give you, say for example on the first test, if I give you a table like this, right, and ask you to give me all the examples of redundancy, you should be able to spot it. And then you should be able to explain why update leads to inconsistency. Yeah?
I'm having trouble seeing where it's unnecessary, right? That's what data redundancy is.
Right.
It's necessary to have the phone number next to the name, so...
That's a great question, right? It's a very good question. It's in this case, the way the table is structured, you're supposed to enter the phone information. But later on, when you design the database, you see that should be avoided. The structure itself is problematic. Right? So given this structure, yes, you have to enter the phone. And as a result of that, you have redundancy. And as a result of redundancy, you have inconsistency. Right? So you see the relationship between these. So data redundancy leads to inconsistency. And of course, the inconsistency results from insert, delete, and update. Anomalies. So you see the relationship? See it, right? Good question. Yeah.
There are different project codes, though, so how would you set that up differently? So because he's managing different projects, so
Yes.
how would you set that up differently so this does not have the redundancy?
That's also a good question. So redundancy here, again, in this structure couldn't be avoided, right? So the rule of thumb for the, and it's going to apply for the rest of your life. Don't you like learning those rules of thumb? That would be good for your entire life. So the rule of thumb here is that every distinct data set needs to be in its own table, right? So given that, what would you do?
Just make a different table for each project, or
For each distinct data set, you're very close. So you need a table for project,
gotcha.
and then you need a table for managers, and you need a table for other stuff. All right? You with me on that? Okay. So once again, in database design, every distinct data set, not every distinct record, but every distinct data set, which will contain a bunch of distinct records, needs to be in its own table or have its own table. Such as student would be in its own table, faculty would be in its own table, buildings, right? And other properties such as desktops. They all have their own table. You don't want to store desktop in the same table as students, even though those desktops are assigned to students, or classrooms or dorm rooms are assigned to students. You don't want them to be stored in the same place, because then you couldn't avoid redundancy. And when you have redundancy, you know your life will be ruined. I always issue a challenge to my students, to play ping pong. Right? I've never been beaten by a student. No student has even come close. The last few times, I've been able to beat my student without moving my feet. In other words, once I serve the ball, I do not move my feet, and I will still be able to beat my students. Relatively easy, fairly easy. I'm not bragging. Okay. And last thing, I want to challenge you. So keep that in mind. We'll play for Pepsi. So that's what database design, where database design comes in. So database design is a very critical part of building a database, so that you design a database so that you accommodate all the possible requirements, right, that you have identified, and also in such a way that you reduce redundancy for men. Now, it's easier said than done, as you can see. In each case, you need to have a deep understanding of the domain. If you're designing a database for human resource applications, then you need to understand business rules in that area. If you're designing one for KFC, then you need to understand how KFC operates, or Humana, for example, or UPS. And their business rules are very, very complicated. There are always exceptions. So that's why database design is so much fun. In fact, for that matter, application design, right? When you build an application, you first of all have to design, right? Classes. You've done that. You design a class hierarchy. And so you don't decide that sales employee inherits from employee, right? Unless you're told that sales employee would have characteristics that are found in all employees, such as name, social security number, etc. So database systems, of course, are an answer to those problems we identify, such as data dependence, structure dependence, and data dependence. And we usually say DBMS, and sometimes you hear people say RDBMS, Relational Database Management Systems. So, but usually a database management system is relational, so people simply drop relational. And it eliminates most of the system's problems. It says eliminates, it doesn't say removes. And this is a little deceiving. By merely using a database, a relational database management system, you do not eliminate redundancy. Okay. You still have to design a database so that redundancy is reduced to a minimum. So without proper design, you can be using a relational database management system and have lots and lots of redundancy. All right. If you do want to play me ping pong, just discreetly contact me. We'll play. If you lose, we don't say anything. Okay? That's happened a few times. We'll play, and then if you lose, nobody will know. I swear I wouldn't tell anybody. So that's, you see, look at the picture, right? Down below you can see a file system, then you have three major systems. And in a database system, you have one single point of entry, which is the database management system. So everything goes through that. So it's easier to control, right? You can easily see that. If you have different points of entry, people coming into and out of the building, then it's really difficult to control who comes in and who goes out. But if you have the same point of entry, so that is what a database system is, and it has 5 major parts. So hardware, you can easily see why we need hardware. Software, which is the database management system itself. Now, I would like to ask you to download the latest version of Microsoft Visio and the latest version of SQL Server. I think it's 2008. Please get the software as soon as you can. Visio, more importantly, than SQL Server. I'm going to post a set of commands, some hints on how to install SQL Server. But Visio should be fairly straightforward to install. So I'm not going to post anything on that. So Microsoft Visio, if you haven't already done so. In 320, I think you may be using Visio to do designs, and you may already have it. But if you don't have it, you need to have it very, very quickly, because we'll be using it in about a week or so. Microsoft Visio. I think it's 2010. And you know where to get it, right? I think you all do. By virtue of being a CIS student or taking a CIS class, you have access. If you don't, let me know. I will help you set it up. Okay. And for those using a Mac machine, and you have to have a Windows partition to use SQL Server and Visio. I hope you do. I have Boot Camp on my machine, and so that's the solution. Most of you have a Windows machine. So I see 2 Macs in the room. And so if you want to use a Mac, then of course you have to have Windows partition. Otherwise you would do it. And of course you have people. People is the most important component, always. They're always the most important component. And you cannot ignore that. And your ability to succeed in your career depends a lot on your ability to communicate, interact with people. Procedures, business procedures, processes, you always have to follow that, right? In some companies, you have higher level of security, like Humana. I worked for Humana before as a consultant. And when I walked into the building, every mobile device would be disabled because they can't afford for you to steal data in flight. We could do that. We had a CIS group student, 323. wrote an application to capture information in flight here on cameras, right? So they were sending information, they could steal that. So that's procedure, and of course data is at the heart of any database. Okay, so we're going to focus on the data part, and of course also software to some extent. The software is DBMS, Database Management System, SQL Server 2008. It's not difficult to use, and anywhere you go, you're going to ask the question, what database management, what DBMS do you use? Okay, it's a perfectly legal question to ask. And then, of course, they'll tell you we're using SQL Server. More likely, if for a large company, you'd be told we're using Oracle. And so if you're using Oracle, then you use Oracle's client. If you use SQL Server, you use SQL Server's client. If you're using DB2, then you use a DB2-related client. I've never used DB2 myself, but it's fairly similar to all the other database management systems. So there's this software, and of course there's always third-party software that you can use to access all database. If you have several databases, I was a DBA before, so I had Oracle SQL Server databases, and I would use a software to manage both types of databases. Okay, so this is another picture. Any questions? Discussion? Complaints? Complaint is fine. And we talked about this, so I'm kind of going to go through this fairly quickly. You know what an operating system is, right? DBMS software, we talked about it. Application programs and utility software. And people, you have all of these procedures data. So when we say you have a database system, please note it usually refers to all those components. People tend to think of the database structure itself and the data that are contained in the database. But it's much more than that. Now, DBMS is going to be an important part of your life, SQL Server, in this semester, so we'll talk about DBMS. So what exactly does a DBMS do? Right, that's the topic that we're going to address next. Most functions are transparent to users. So most of the things that the DBMS does, which are very, very important, transparent to you. In other words, you don't even know that they exist. You don't have access to those programs, or you can't change those functionalities. That's what it means. And it has a data dictionary management. The data dictionary is a collection of metadata. It's not just data, table names, attribute names. You know, when you have a student table, you have a student table with a student ID and student name and say student phone. And of course you typically would have other fields. I would say I wouldn't be surprised to see a student table containing 30 fields. That's very common. Very, very common. And so student ID for us is a 7-digit integer, right? And name, of course, is name, and phone is phone. And so the fact that there's a table called student is in the data dictionary. The fact that the table student has SID, type integer, SName, type string, it's a variable length string of, say, 30 bytes. I'm pretty sure it's more than 30 bytes. and the phone, which of course may have a specific structure, right? It's phone numbers here are usually they usually impose a structure on that. So that's part of the data dictionary, and it's much more than that. It's also relationships, in that the student table is related to the class table. Now, please note, I'm using the nouns in the singular to denote tables. And that's just a convention. In some companies, you may see nouns in the plural, like students. But typically, you would see singular nouns used as names of tables. So, student. But please note, it implies that the table contains a bunch of students. You wouldn't have one table for each student. I mean, that's just doesn't make any sense. Okay. And the table can just go on and on, right? The student table, you can have more and more students. And I was surprised to find out that the University of Wisconsin in Madison, at least that's what my daughter told me, has 48,000 students. That's a lot of students. Why would you have so many students in that little place? I don't understand. But that's a huge campus. Ohio State has 40,000 plus, and Louisville, of course, is 26,000. So once you have built the table, of course, you have an additional student, you just add to it. Of course, when you graduate, you get removed into another table, alumni table, for example, or some such table. And so this is a huge part of a DBMS functions. So a DBMS has the ability to manage all of these data. They store them someplace. And if you become a DBA, it is critical that you understand what structures are used, how they can be retrieved, how they can be managed, and so on and so forth. But in this class, we're not going to be concerned with that. So that is simply a Oracle, I think it is. Maybe it's SQL Server. It is SQL Server. The Oracle looks very much like this. It's a SQL Server client software. That's the interface. As you can see, the interface is very, very intuitive. If you have used Windows software, it's fairly straightforward. Okay. Data storage management. Now that is also a huge part of DBMS's job. But most of it is transparent to us. So when you say you add a row to a table, another student decides to attend U of L, the student's information will be entered into the database, and that information will then be added to the table. Now, where it actually ends up on a hard drive, you don't know, and you don't care. Usually, a large database system would have several drives. So you would have data stored in different physical locations. And this is important because you want to be able to retrieve information, different sets of information concurrently. Say, for example, if you are finding out what people are taking what classes at what times, then you want to be able to retrieve the information about students and classes together. And you don't want them to be at the same physical location. Because, I don't know if you have opened up your laptop, but for a disk drive, you have a bunch of CDs together, drives. And this is a read-write head. It's called read and write head. And of course, flash technology is different. And what it does is to move in and out, right? And this is always spinning. And then it has the next one, and the next one, right? So there's several of these. And as it spins, the read-write head will be, of course, on the top of the track, and that's how it picks up information. Right? These are all mechanical devices. And something that you can touch, and if you step on it, it'll break. And so this is called seek time. In other words, the amount of time it takes to find out which track the data resides on, the seek time. That's mechanical movement. Once you have brought data into the memory, then the processing is much, much faster because that's electronic movement, right, in memory. You know that your, how much memory do you have on your Mac? 4 gigabytes. And how much hard drive? So usually that's a typical ratio, right? You have much more hard drive than memory. Okay. So, and I don't want to brag, but I have 8 gigabytes on my Mac. I love it. It's really, really, really fast. And I bought this, download this free memory program. Free memory. So I always would have 2 gigabytes free. So that's really nice. So I like to brag. I'm sorry. I'll control myself. So memory is usually fast, but it's volatile, right? If you turn off your machine, the information that's stored in memory is gone, right? And so therefore it's fast, but it's volatile, it's not permanent, and it's relatively small relative to hard drive. But hard drive, though, is slower because retrieving information from hard drive requires mechanical movements. Now, if you have a flash drive, then it's faster. I think medical care uses flash memory. It's faster, it's newer technology. But it's more expensive, right? I don't know how much would 1 terabyte of flash memory cost. Do we even have 1 terabyte? Do you know? It would cost a lot of money, right? So, but for large database systems, you need sometimes a few hundred terabytes of storage. You just can't afford to use flash memory. It is physically impossible. So, therefore, retrieving information from the physical devices is going to be slow. That's why we have data on different hard drives so that they can be retrieved concurrently, right? And once they arrive in the main memory, then we process them. And once we're done with them, they're written over by a new set of data. So that's how swapping in and out of data and programs, too, in memory, that's what the operating system does, right? So we have all of these things that are happening in a database system, but that's all managed by the database management system. That's what they're for. So, and our database server sits somewhere in the IT's, I don't know where, to be honest with you, and it's not important. And you can access, we've set up security so that you can access it anywhere, okay, even during spring break. Spring break is March, right? That's when things get really, really difficult in this class. So, no spring break. So, data storage management with Oracle. And Oracle allows you to fine-tune data storage, allows a DBA, database administrator, to set up your database, physical features of your database, so that your database runs faster. Data transformation and presentation, of course, that's also important. And data transformation, you see some of that with SQL Server Client. You're going to have that client. You're going to install that on your machine. When you're ready to do that, and you still haven't seen the post for the demonstration of installation process, let me know. I'll post it. I'll try to post it sometime this week. And in transforms data, you have data in different formats. You can transform it. You can load it from Excel, Access, into SQL Server. You can load it from Oracle into SQL Server. If you have a text file, you can load it into SQL Server as well. And security management, this usually becomes more and more important, but you will not do any of it in this class. But we do have a database security class. Actually, we offer a section of it this semester. And you take that, and that class is concerned about security. And the only thing they're excited about is security. Of course, the instructor assumes that you have taken database. And multi-user access control. And multi-user access is really important. To give you an example, if you go to Amazon, buy a book, right? And there's only so much inventory, and 3 people could be buying the same book at the same time, and there are only 2 copies. Okay. And I think that's what happened to Fahrenheit 451 or something like that. Or 71. What do you think? 51, 71? 51, okay. So I ordered that, and I got a note saying your order was successfully executed, something like that. And the next day it said, no, the vendor has sold out. The book was sold out, right? So that could be the reason, because several people were ordering, and the system was slow. But a good system would be able to have multi-access control, so multi-users are trying to access the same piece of information or update the same piece of information, like reducing the inventory by 1 each user, or 2 or 3, right? Depending on how many copies you're buying. So, that of course is important. And speaking of 451, I immediately it was a penny each. So I didn't get that, so I went and bought a 99-cent copy. And of course, my daughter texted me yesterday saying that the instructor found a copy for her. So I went to cancel the order, and it was already shipped. No return policy. It was a used book. So I'm out of $5.28. $5.28. That's a couple of really, really good years. So, but we have an extra copy. We'll just donate it to the school. My official policy is that my students should avoid alcohol like they do redundancy. No alcohol. It's bad. You hear that? It's being reported. Advocates abstinence from alcohol. No alcohol. Backup and recovery, that's really important. I have set up the database management system's backup data at 2 or 4 a.m. each morning. I think it backs up each day. So maybe once a week, I forgot. It was set up such a long time ago. And because you can lose stuff, right? And the database sort of crashed, and you may lose information. So it allows you to recover your data. So that's backup. Once again, you're not going to be involved in any of that. Integrity management, you will be doing that, and you're going to do that mostly through a sound database design. So you're going to follow principles of database design that we teach in this class, so that you create a database design that reduces redundancy to a minimum. And again, redundancy is to be avoided. It can lead to all kinds of problems. You maximize consistency as a result of reducing redundancy. And of course, you have enforcing database relationships and all of that stuff we won't be able to talk about until much later. And then, of course, SQL, structured query language, is the language to use to access a database, or to update the database, or to retrieve information from the database. So that's pretty much what you use to interact with the database. And it's very different from C# in most of its use, in that in C#, I like to use this example because it makes you think. In C#, if you have to find a list of the students whose GPA is above the average, can someone describe the logical steps you follow in doing that? I want to list the names of all the students whose GPA is above the average. Assuming I don't know what the average is.
Well, you'd have to first get all of the students and the averages, and then you'd have to test and see which ones are above what you want, and then you'd have to get it listed.
Okay. How would you find the average? What's the logic for finding the average? Assuming you have your data in an array.
You just kind of loop the searches through the array. Every whole together.
Okay. So you have a loop. That's correct. You have a loop. You loop through the array, and you have a running total called sum, something like that. Total, right? You add them up, and at the end of the loop, you divide it by the number of students in the array, and that you get the average, right? And as you were saying earlier, once you have found the average, then you use another loop, right? And you loop through the same array again, this time comparing the average that you have found with each of the students in the array, right? To see if their GPA is above the average which is found, right? That's the test you're talking about. So if it's above the average, then you display the name of the student, say congratulations, and below the average, do nothing, and then of course at the end of the loop, once you have run through the loop, you will have to display the students whose GPA is above the average. Is everybody with me on that? Okay. So that's in C#, right? And so that's about what? About 50 lines of code, at least. What you saying? 50 lines of code, right? Assuming you have all the classes properly declared, like you have an array of class objects, right? And each object would have a name and an attribute called GPA. Now, in SQL Server, assuming that each student, the table student, stores student name and GPA, this is what you would do in SQL Server. In SQL, you say select student name from student. That's the name of the. I'm not teaching SQL, of course, today. I'm just giving you an example. It's okay to completely forget the example today. So where GPA is greater than select. Okay. So that's your first loop. That's your second loop. That's just 3 lines of code. That's all. That's all you do in SQL. So SQL is a declarative language. It doesn't. You in SQL, you tell the computer what it is that you want. Right? I want average. And from where? In C#, you have to tell the machine how it is that you would like to do what it is that you want to do. Right? You have to have a loop, while, okay, or use for loop if it's an array, and then you have to use an if statement, and so on and so forth. So that's SQL. And in SQL, this will be executed first by the database management system, DBMS. The average will be found, and then that value is used to find those that are greater, whose GPA is greater than the average. So still, the logic, underlying logic is still the same, but you don't have to spell out the logical sequence of steps. So in that sense, it's a lot easier. That's why a lot of business analysts can pick up SQL. But SQL also has a set of programming constructs that allow you to do the wonderful things that C# allows you to do, such as loops, if statements, and so on and so forth. And we'll do that towards the end of this semester. We'll write large programs. Any questions? Think you still like database? And of course, this communication. It's important. And again, it's not going to be part of this class. And most of you will be accessing SQL Server wirelessly from your laptop. I don't know, does Android have a SQL Server app? If so, when you can access SQL Server from Android. And so that's a part that we are going to, of course, completely skip. Managing the database system, and database systems are becoming more and more sophisticated, but human, of course, involvement is still highly desirable. And for large companies, you have hundreds of databases. Hundreds. Okay. UPS here in Louisville, just for the air operations, they have 300-400 databases in active use. See? So they have a group of people whose job it is to maintain the databases. And those people, of course, will be on call. Some of those are our friends, and sometimes we're talking, this female DBA, she would bring her laptop with her all the time. I said, why do you have to do that? She said, I'm on call today, and of course the company pays for Wi-Fi access and so on and so forth. So she would have a laptop, and when she gets a call, and she has to go on the laptop wherever she is. Okay, even when she goes to watch the games of her daughter, she would have to bring the laptop. And of course, if she goes to somewhere without Wi-Fi, then she has to call the company before. And then she would have a cell phone, and then I think it's cell phone enabled laptop. That's what she does. So that's how critical it is, right? And you have to have constant, make sure that the database is always active. Disadvantages, increased costs, it's expensive. Like I said, even though SQL Server is not expensive, but maintaining it, to use it for real operations, it can cost. You cost by the number of users. Now, of course, Microsoft has given SQL Server for us for free. And that's what they do to build a loyalty base. And it's complex. If you have large databases, then it's complicated to manage. And the complexity is only limited by your imagination. Okay, very complicated. And that's why these DBAs are well compensated. I know that our Oracle DBAs here in Louisville, U of L, which underpays people all the time. Right? It's about 100,000 if you're an Oracle DBA. So, in large companies, if you're a leading DBA, you're doing very well. I know a CIS student who graduated 10 years ago. I met him 5 years ago. I saw him 5 years ago at the stadium football game. He was the manager of the DBAs at Papa John's. You know, John started selling pizza online. He said that application almost killed him. Because there were so many people involved, and it was so critical. Now you're online, people may come online anytime to order pizza, and there are all kinds of complexities. And then of course there's vendor dependence. You buy Oracle. If you that in 320, that's going to be important. If you use, in theory, okay, if you buy Oracle, switching to SQL Server will be very costly later on. Or if you get SQL Server, switching to Oracle later on would be very costly. And simply because these two products are not the same. In theory, they all are based on the same principles, but they have their own idiosyncrasies. And applications, of course, would have to be modified, and database designs would have to be changed. I mean, it's just a nightmare. So, things for you to keep in mind if you happen to be involved in such a process. Upgrades, replacement cycles, and all of those good things. So, we have a couple of minutes left, and I would like to devote that to the assignment. But before that, do you have any questions? No questions? Okay. The assignment, let's go to Blackboard. It's under assignments, and it's due the 18th, which is Wednesday next week, and it's 20 points. Please note that it's due at the start of the class. All the assignments, when submitted, will be automatically marked by Blackboard. And I have set a time for it about 5 minutes before class. Something like that. I forgot exactly when. About 5 minutes before class. So, or maybe 5 minutes. Maybe just 1 o'clock. I think I said it at 1 o'clock. So if the assignment comes in after 1 o'clock, it'll be marked late. And you need to finish exercises 5 through 8. And on page 27. And you will submit both an electronic copy of the assignment and a physical copy with your name section, your name on the cover page. And so it has to have a cover page. You don't have to have a cover page. You can just write your name on the first page, but it has to be on the first page. If the page is not stapled, I'll take points off. But in that case, you have to write your name on every page. Just staple. Borrow stapler or something. They have a stapler there in the Student Advisor Center. I can just go there and staple. And so let's take a look at the problems. So if you take a look at P1.5, it has a somewhat similar structure to the example we talked about in class earlier today. And number 5, identify and discuss the serious data redundancy problems existed by the file structure shown in figure P1.5. Right? So you need to give examples. And so you see what's redundant, and remember we talked about how redundancy leads to inconsistency and update delete and insert anomalies. That's how you discussed it. Any question about that? Okay. Looking at the employee name and employee phone contents in 1.5, what change would you recommend? Okay. And just take a look at that, and if you can't think of any change that you would recommend, email me. So, if you want to ask the question now,
like we talked about earlier, would it make more sense just to have a separate table for the employee plans and the employees?
it would, but it doesn't. It's not pertinent to this particular question. It's more. This question has to do with the structure of the field rather than the structure of the table. The tables. So think about that. And identify the various data sources in the file examined. So data source, for example, student is the data source, class is the data source, right? And computer is the data source, rooms is a data source. Right? So in that sense, I would like you to identify the different data sources that you see in this table. That's what creates redundancy, right? You have these different data sources being captured in one single table. So you have to repeat things. You see? So you identify all the data sources. Number 8, given the answer to problem 7, what new files would you create? Here, of course, is what they actually mean is that what tables would you create to resolve these data redundancy problems you identified. So what do you think? Do you think you're about half an hour away from finishing the assignment? About an hour away from finishing the assignment? Questions? So try to do the assignment and do not hesitate if you have any questions. Do not drink during the break.